that you look at it and you can say, how am I going to figure out that out next time? Or maybe it's my fault that we didn't cover it like that one thing did. If you would jot this down under exponents, the little subheading today is the laws of exponents. And these are not intuitive, which means what, Riley? If something's not intuitive, what does that mean? Anybody? Something is not intuitive, you should hear that again. In the language of learning, or in any other language, the word intuitive comes up there. Anybody want to speculate? It's like, what was speculate? Intuitive means if something's intuitive, it's like it makes sense, it's the way it should be. This is not like your first thought that's going to come to you. For example, here's the deal. If you have this, if you have, I don't know if I want to use letters or not. Yeah, let's do this. If I have x to the third power times x to the second power. This is what I mean with intuitive. If I were a 7th grader and I looked at this problem, I would say the answer to that should be x to the 6th power. Because it's multiplication, and when you multiply 2 times 3 and it's 6. That is incorrect. Okay, the answer to that, does anybody know what the answer to that actually is? Think about this. What does x to the third power mean? X times x times x. What does x to the second power mean? X times x. Is this x to the 6th? No, it is x to the 5th power. And that is not intuitive. That doesn't seem quite right. Okay? The rule for laws of exponents is this, and this is what you should make sure you write down. When you multiply like bases together, you add exponents. This thing's getting in my way. If the bases aren't like, you can't do anything with it. For example, if I have a squared times b squared, you can't put those together and say that's a to b to the 4th. It's not. It is a squared b squared. You can do nothing to simplify that. They have to be like bases. If you have y to the 3rd power and you're multiplying that by y to the 8th power, those are like bases. In order to add them together, you add the 3 and the 8, and you get y to the 11th power. Because you have 3 y's times themselves, another 8 y's times themselves, that's a grand total of 11 y's times themselves. You gonna comment on my intuitive, counterintuitive, non-intuitive? Yes, I like.
So it's late happen when we're doing letters, not numbers?
No, well, numbers it would be the same thing too. But it has to be the same number. If you had 5 to the 3rd power and you were multiplying it by 5 squared, that is going to be the same thing as 5 to the 5th power. Now, will they ask you to actually multiply that out? I don't think I would take the time to do it because that's a big number. 5 times 5 is 25 times 5 is what? 125 times 5 is what? 625 times 5 is 3,125 or whatever it would be. You know, I would watch and see what the book tells you to do there, but I would just leave it as an exponential form as they look at it. Isn't that exciting? Well, unfortunately, we've got 2 more laws to go over. Again, neither one of them are really counterintuitive. Or, I mean, neither one of them are intuitive, but they're counterintuitive. How about this one? Check this out. What if I have x to the 3rd power, and then I have that to the 3rd power? What if I have a power to a power? What happens there? X to the third to the third. Well, I'm just gonna, let's break it down to what it really is. What does something to the third power mean? This means I have x to the third times x to the third times x to the third, correct? 3x to the third, all to the third power. 1, 2, 3 of the same thing multiplied together. Well, and x to the third power means you have x times x times x. X to the third power means you have x times x times x. And x to the third power means you have x times x times x. How many x's do I get there in the end? X to the third power. Brooklyn, doing her 7th grade math, ends up with how many x's?
9.
Yeah, this equals x to the 9th power. I will do one more and then I'll see if you cannot get what the law of exponents when it's exponents to exponents are. What if I have the letter m to the 2nd power to the 5th power? If I have 5 m squareds times themselves, without going the whole next step and writing all those m's down, how many m's or what am I going to get there? Yes, this is the portion of the show where you, Lainey Kavari, venture a guess.
M squared or M
M to the 10th power, very good. So, ladies and gentlemen, what is the rule when you have exponents to exponents? Exponents to exponents get what? 3 and a 3 gave me 9. 5 and a 2, where did that go? Gave me a 10. Exponents to exponents, Aubrey, get 3 and a 3 gave me a 9, and a 5 and a 2 gave me a 10. See a pattern there? Very good. Get multiplied. So if I had b to the 5th power to the 5th power, without having to write all that stuff down, my answer to that is Luke Franklin, b to the 25th. Now again, don't get this confused with this. B to the 5th power times b to the 5th power is not exponents to exponents. This is what we just did prior to this. This is a base, same bases getting multiplied. The answer to that is b to the 10th power. Okay, this is not exponents to exponents. This would actually be the same thing as b to the 5th power squared. But b to the 5th times b to the 5th is b to the 10th. Wow, so much to do, so much time. And then we've got this one. One last one. What do you get if you have x to the 5th power divided by x to the 3rd power? Or maybe I should have made it 6. Let's make it 6 just because. Intuitively, you would say, well, since that's a division problem, it should be 6 divided by 3, and I get x to the 2nd power, which is incorrect. What actually is it? Well, if we boil it all out and do it all out, x to the 6th power means you have 6 x's, which sometimes they write up here, sometimes they don't. And that's all over 3 x's. If I have this, what happens when you multiply the same things over top of the same things or whatever there? Yeah, if you have exact same things, you can cross them off one for one, so that would go away. That would go away, and this would go away, leaving me with this, which is x to the 3rd power. So x to the 6th divided by x to the 3rd is x to the 3rd. Think we can slip into the proverbial twilight zone and get, what do you suppose happens when you divide? When you divide like bases, Elijah, you?
Subtract.
Yes. Subtract. What is that awful noise? It's like ultra loud.
Oh, it's right here. It's fine.
Got that? So, and again, it has to be like bases. You can't do anything with this. A over b squared, nothing can be done with that. They have to be the same bases. It has to be an x and an x. Now, you could take a to the 7th power over a to the 2nd power, and that would simplify and give you somebody going once, going twice, going 3 times. Lady Kavaric?
A to the 5th power.
Yes, a to the 5th power. A to the 5th power. What say you on that? Open thy beloved books to page 178. This was a lot to give you all in one